welcome back. Tuples. Tuple is an immutable sequence of objects. Because tuples are immutable, immutable means cannot be changed, okay? Python can implement them more efficiently than the corresponding list and need only support a subset of the behaviors afforded to list. So list has many behaviors, many of those mutators. The mutators do not cannot be implemented for tuples. Okay. The literal form for tuples uses enclosing parentheses with commas separating individual elements. For example, person equals parentheses string first name, comma, string last name, comma, string profession, close parentheses. Tuples support all the non-mutative behaviors of the list that we summarized in figure 2.2 with the exception of count and index. So figure 2.2, construct a few tuples and implement every tuple method from figure 2.2. Okay, so this is 2.5 for a string. Here is 2.2 for a list. Notice there are the mutators, they don't apply for a tuple, okay? So these will not work, but the accessors will, and these also could, okay? But they also mention, anyhow, try these two and see which ones work and what happens and so on and so forth, okay? So do keep in mind they also mentioned that count and index will not work. So check for yourself. Okay, now come the numeric types: int, long, float. There are 4 different primitive types for storing numbers. 4, okay, we have listed 3. What are the 4? Int, long, float, and complex. There is a maximum magnitude for a value stored as an int. So int, int is slightly different from integers. Not slightly, conceptually they are different. Why? Because integers are infinitely many. Likewise, real numbers are infinitely many. Complex numbers are infinitely many. Our computer, no matter how big, does not have infinite amount of space. So it cannot possibly store all the infinitely many numbers. So int are only finite number of integers basically. But Python is such that beyond that limit, Python has a long class, long integers that can perfectly represent integers with arbitrarily large magnitudes, although with a more complicated internal encoding. The point is, Python automatically converts from the use of int to long when necessary. It automatically, so if you have a very large integer, Python is able to compute. Mind you, many other powerful languages are not, but Python can because of this automatic conversion from int to long. With Python 3.0 onwards, long has been dropped, okay? Because everything automatically converts, and 3.0 onwards, long simply got dropped. So now we have only int and float. Complex are also there, but we won't work with complex in this course. So we are not worrying about that. All right. Floating point representation. Floating points are also, these are numbers here meant to represent real numbers, that is with decimal points. Again, real numbers are infinitely many. We don't have infinitely many floating points. So that's why there is a distinction between floating point and real numbers. They are different conceptually. Okay. Now, in Python, these are stored using a class named float. Note, 3.0 belongs to the float class. 3.0 is a float, even though it has no fractional part. So 3.0 is different from 3 in that sense. Okay. So as I mentioned, we will not be working much with complex numbers. Now, here are certain operators, some selected operators for Python's numeric types. Plus is for addition, minus is for subtraction, star is for multiplication, forward slash for division, double forward is the integral quotient or the floor division, percentage is for the remainder or the modulo. Okay. Double star is exponentiation, x power y, also available as POW, POW, x, y. Negative x is the negated number. ABS, absolute value of x. Okay, these are all built-in numeric type operators. X double equal, so this is the conditional, right? Is it equal to y? So it will return a Boolean value, either true or false. Exclamation equal stands for not equal. Is x not equal? So this is also a conditional. It's asking whether x is equal to y or not equal to. So not equal is going to return a Boolean true if x is not equal to y. Is x less than y? Again, a Boolean return. Is x less than or equal to y? Boolean return. Greater than, Boolean. Greater equals Boolean. CMP. Okay, minus 1 if x is less than y, 0. Check this. Some of these methods, they go out of service basically as Python gets higher. And anyhow, CMP is for comparison. X less than y returns a negative 1. Okay, I could check here, but I want you to check. All right. Double forward slash represents integer division. Percentage represents the modulo operator. So percentage gives you remainder. Double forward slash gives you quotient. Numeric types are immutable. If I say age equals age plus 1, it does not alter the value of the original. So for example, age was here. Age now moves here, but the original value has not changed. It's the label which moved to a new object. Okay. Now, here is the last topic of this particular lecture. It's a short topic. Type conversions. Try these for yourself. Converting information from one data type to another is called casting. Casting is converting information. Okay, type conversions, casting. Try the following conversion commands appropriately. Int, float, round, str. Okay, so say for example, int of 5, it is 5. Int of 4.5, it is 4. It gave me the integer value of 4.5. Int of 3.0 gave me 3. So 3.0 was float. Now I have an int value. Okay. Mind you, you can also try the following. Int string 35. You see that string, and it gave me int value 35. The same thing. Let's look at float. Float of 3. 3 is int. Float is 3.0. It gave me a new object, new type even, float of codes 34.0. So notice it did not just give me 34, it gave me 34.0. Okay, what about round? Round 34.5456. Let's see, what does it give me? Give me 35. Why did it do so? It had to round. Round meaning completely ignore after the decimal point, keeping in mind the very first place after the point. So if this digit is 5 or higher, you round it up. So notice for a round, I am getting an int return. Now suppose I were to do round 34.5456 for 2 decimal places. 2. Okay. So let's see what it does. Aha. It gave me 34.55. So this 2 told me 2 decimal places after the point. 1, 2. So how do I round it up to 4? I look at the following place digit. That's a 5. So this 4 became a 5. So let's do something interesting, right? So say if I ask it 34.5967. All right. Oh, up to 2 decimal places. So let's see. Aha, that's beautiful. Exactly what you expect. So 2 decimal places means after the point, I have a first decimal place, second decimal place, so 9. So I'm focused on 9. I look at the next guy. That's a 6. So 9 should go up. Well, when 9 goes up, you get a 10. 10 means the 5 becomes a 6, right? And it gave you the correct answer. So that's what round is for.